Okay, shall we just start? So first, thank you everyone for joining the session today. And it looks like we get a small group today, which is great. I think it just means that we may have more spaces for the discussions and questions. Yeah. So I also know that the FinOps topic, which is not as popular, as sexy as the AI topics. But trust me, the FinOps can save enough money for you to pay for your AIs. A little bit about myself. My name is Yihui Xu. Originally come from China, and I have been in Norway for 24 years. I have been lived longer in Norway than have been in China. I have been worked more than 10 years on the cloud platforms. Start with AWS, then jump to Azure, and work in Kongsberg Digital now. But my background is not only cloud. So back to the years, I have around 20 years experience in the security domain. So from the Windows, Linux internals, malware analysis, reverse engineering, software integrity protection, code obfuscator, Then when I start, one day I just decided to jump to the consultant industry. Then I began to play with the cloud until now. So today, I want to talk a little bit about something that the engineers actually don't often think about, which is the cost. So especially, we are talking about every single architecture and the technology choice, so may affect your bill. And it can appear as a line of items in your cloud bill. So may I ask a question? How many of you have seen your cloud invoices? And have it ever been surprised you? Oh, it's great. Yeah. They are making the good progress. So let me start with one story. So this is one very classic architecture, which we can find on the internet. This is for Azure. So the front door, or they have the CDN profiles. Then they go into, can distribute the traffic to the closest destination. For the load balancer, load the traffic into different workloads. They have storage, they have the monitoring, logins, and everything. So anyone can, are there any issue or error on this architecture? So basically, this is pretty much followed by Azure's best practice, and many companies are doing it this way. And this is a typical active cross-region deployment. Geographic distribution have the high availability, and they also have the edge cache to distribute the traffic to closest location. They have logins, monitorings, and by this active architecture or deployment, so the RPO and RTO are closer to zero. So, and I would believe if we do in this way from on the infrastructure perspective, so it will have a pretty good performance, at least in the first period. And then the development team or infra team, they will for sure be proud what they have built. Until one day, the financial manager calls, hey, how can this cost so much? It was 40% higher than what we have planned. So what do you think, where the money can go? There are quite a few things can go. For example, every single gigabyte of data has been replicated across the region. Between this one and this one, for example. Or if they have any persistent volumes. They have a data replication inside of the hard disks. They will generate a lot of money because of the bandwidth. And you have storage here. You will get the ingest data from customer. Each single gigabyte of data will be replicated twice, plus the processing time, processing cost. It will at least 2 times more expensive. And also, when we talk about storage, we will talk about, are you in your system or in the system, it is always you have high frequent access to all of the data. Most likely not. Some of them are called, we can put it to somewhere else, which give a better price. So even technically, it looks perfect, but it can give some surprise from the cost. Active deliver near perfect uptime, but always come to extra invoice in the invoice. So when we try to understand why it could happen, then we have to go a little bit step back and to see what cloud is. Many times, people are comparing electricity together with the cloud. Why? Because all the time, we do agree, electricity, we pay what we have used, and the concept from cloud are the same. Now here I want to say, only on the surface level, it is true. Because when we walk through this bill, electricity, I spent 146 kilowatt. 446 kilowatt, which costs 146 cents per kilowatt hours. It's very simple. Everyone understands it. Come to here, I just expand a little bit from the storage bills. They have different storage tiers. They have different operations and data stored operation, index, list, read operation, archive. Some of them maybe also have recovery, a lot of different things. We have virtual machines, we have networkings, we have security, and it's too complex. So, therefore, everything, let's say we write something into the storage account in Azure, it will occur list, write, and stored, the 3 costs, at least. So every single decision eventually will land on the bill. So the invoice, in fact, is a shadow of your architecture. And it's also, we can also see this is a mirror to reflect your designs. So how can we design this smarter? And it will come to the FinOps lens. As an engineer, we always working on technical balancing trade-offs, fighting with the performance, fighting with the reliabilities. So the cost of FinOps, they actually is not a blocker. They just add another dimension to this, to this requirement. So we can take one example is that when we work, there are 2 teams. One team, they are fighting with the performance and reliability. They make it done, technically perfect, up and running, good. And another team, they do have the cost in the mindset, and they care about the cost during their design. they were able to, for example, save 20% of the cost by the end of the day with the same performance. So this is the difference. So, but many times, I do agree that not all of the engineers used to think in this way, because we always get told, hey, can you do it fast and high performance? This is, we have been told by our product owners, very often. So this is the challenge, and this is exactly the things we want to challenge. So let's have a look what could happen if we don't do that. There are a few examples. Auto-scaling is very essential in many deployments because we do need to scale our resources, adjust our resources to meet the real-world traffic. For example, we have set up the auto-scaling policy. If the CPU utilization is over 60%, 70%, then we will trigger the HPA, the pod auto-scaler, and eventually it will also trigger the node scaler to spin out a new virtual machine to give more capacity. Storage, we want to save everything, and we want to give the best performance to our customer. So, especially in the beginning of a lot of startups or people who start with the cloud, they are just trying to use the default and the best services, get up and running, everything looks fine, deployed. Premium hard disk, premium storage, especially for this require low latency and high EOPS. So the premium hard disk really can give very good performance, but 4 or 5 times more expensive. Premium storage in Azure, which costs 10 times more expensive than the hot. We have also logs, observability, metrics. This is another one who will come to burn your wallet. By default, 100% log ingestion without any filtering and samples. It's 90 days retention, okay. In Azure, we get for free for 90 days, but not for all of the cloud provider. Network topology, multi-region architecture, which always occur extra inter-region bandwidth, which costs a lot. So now let's just start one by one. Autoscaler, let's take one scenario. In the midnight, we have some scheduled cron job or backend tasks up and running. But at the same time, we don't really have that much real user in. When the task gets up and run and they push the CPU high, the autoscaler has been triggered, add pod, add node. It can be interesting. So tomorrow morning, people will see the cost curve. We will go this way. What happened there? It has only a CPU as the matrix, as the trigger to trigger the autoscaler. There is no stabilization or cooldown windows. What do you do after you have scaled out or up your resources? You should have a time window to be cooled down until you react or do action to the next scaling. And concurrency model, each pod, each service, it's better to set up the max concurrency to handle the workload you can, and hard limits. max replicas, the pod budget interrupt, etc. So what we can do, we can use more reasonable business metrics, not only CPU and memory. For example, we can use the size of the queues waiting for processing. We can also take the processing time, compare together with the queue size and the drain time, etc., to make a business sensitive metrics as the trigger of autoscaler. Concurrency model, as we said, and set guardrails for resources. You can also, if we have the scheduled scone job, which happened every night, we can do the pre-warm up. Just spin up some resources to be prepared for this workload. And then we take them down afterward. It will be more cost efficient than play with autoscaler, because there is another trap is if the job, let's take one example. Let's say we have one line of function, which is a lookup for 100,000 of items. The efficiency in different language will give you a different result. Python has been used a lot in the cloud-native world. But Python is one of the languages with the slowest for the array lookup. It will push the CPU immediately as long as you run a lookup in a huge area. So what it done, just run one single query inside of area, but push the CPU up. If you have several workloads and you don't have other mechanisms, your CPU will just stay high. It will never get scaled down after the scaling. And also, node pricing strategy. So you can choose a different family size, VM size, and different pricing tier. For example, utilizing a spot instance and something else. So auto-scaling can save a lot of your money, but only when you have this cost in mind. Then what is the next? Storage. Oh, storage can be dangerous. Because one example is the real example is the one SaaS company. I have been worked for them when I was a consultant. They were running very fast on Azure, and they are trying to deploy everything to the customers in a short time. They are very good in the codings, and they are following all the best practice, which recommended by Azure. But one thing will be interesting, because premium blob, they will give single-digit latency when you do the access to the storage account. And in their deployment, their customer is huge. They have, and the customer requires them to deploy several clusters which close to their offices across different geographic regions. And they have 10 terabytes of data, more or less, ingested to the platform every month. Premium block, it costs 10 times more expensive than hot. 10 terabytes, 1 terabyte costs around 1,800. 10 terabytes costs 18,000 per month. And let's say they have 4 regions. It will burn them around 80,000 only for data storing. And not only that, they also cost a lot because they have to do the data replication. Each replication will happen between 2 regions, from West Europe to US East, from US East to Australian, Southeast Asia, and then probably to Central India or somewhere else. So that cost looks like that. It's just increased. And another interesting, let's say we do have the budget. We have one, this costs only 180,000 Norwegian kroner to host the 10 terabytes of data. Remember, this is incremental. Every month, we get 1 terabyte extra. So how much? This is mathematics. Every month, we get 10 terabytes extra. How many we get after 12 months? 78. Because just add-ons. And multiply with 4, 5, the numbers of the regions you have deployed. So what we can do, utilize the hot tier for the active data, and then we also tear down the others. Not necessary to use the premium. I think the statistic from a lot of source says from single digits to a small double digit millisecond latency is not really reactable from the end user. Lifecycle management, put the inactive data to code over time, put into archive. And also, do they need the full data replication across all of the regions? Because it's so seldom that people from Central India go to access the West Europe data. So they do not need that much. And at least not for all of the data. There's another trap here. So this, I just recorded it for before I started. The lifecycle management looks okay. We store data in the hot and put the frequent access data into code, then archive them to the offline storage. Any issues for this policy? But the one thing interesting is the data recovery. There is a price trap. If you have a case going to recover data from archive, that will cost a lot. And the different way you push your data into archive can lead to a huge difference of the invoice. Exactly the same lifecycle policy. So there's one case, the guys have made exact what Microsoft recommended. And one day, accidentally, they have to recover around 5 terabytes of data. After one night, the bill increased 1.2 million Norwegian kroner. And he only able to recover 50 gigabytes. Guess what's the reason? Any idea? Anyone knows about how the storage account prices is based on 10K operations, right? Every 10K operation, it will cost, for example, 0.2 cents. For data recovery, they do care about the size, but they care about the number of the objects you try to recover from archive, which is called the rehydrate process from the archive back to code. And on that particular case, they push the data from code to archive as original files, which is 150K per files. Oh, 1.2 million only for 50 gigabytes. But, yeah, that's so this is an extra bonus. So I just record it. It really can lead huge amount of cost from your cloud. So what we can do, compress them before we put into archive. Done. Exactly. Not all of data deserve premium storage. Then we go to the logs. So if we're talking about the storage is dangerous, the logs, actually, I used to call this a silent killer. Log analytics, CM, everything stream to CM solutions. So let's say over time, the cost of the logs can be easily beat the cost of virtual machines. What we can do there? So we can make the categorization of the logs. We have, because sometimes the developer push the code into the production. They know they should disable the debug logs and info logs, even the PHP styles debug informations. But at the same time, they also need to debugging if any issue occurred in production. So many times, actually, the application logs from info level, warning level are still there. And default configuration in any cloud can be dangerous. 100% ingestion, no sampling, no filtering, 90 days retention. They just lead the cost there. So what we can do, we can classify the data. We don't have to put all of the info warnings to log analytics. We can have a 10-20% sample. That's good enough for tracing perspective. Errors, we can do 100%. Retention period for the dev logs, 1 week or 2 weeks. But for some others, we can put 30 days, 60 days, 90 days. Yeah. And also, when we have really a lot of workload and logs, we can do some filterings of the payload. Not necessarily we have all of the headers put into logs. They just burn the money. Yeah. So yes, we do save a lot everything, especially when you talk with the CISOs. Oh, we need everything there. But how can you save the money? That is not my business. But yeah, by the end of the day, the engineering team or infra team is a blaming point. You burn the money. We can do it better. And then let's go to the microservices architectures. So this is, I just draw it very simple. The red lines means that there is a cross-region invocation of the APIs or the services. So there are the lines they call to each other, and some of them they have the back and forth invoke to each other, which is the typical way that will occur a lot of egress and cross-region cost. So over time, the bigger deployment, the bigger resources, the bigger workload will occur the more network cost. And also, the more complex graph, the higher latency we'll have. We can batch the processing. We can do some caching, and we can also do something differently in the topology. For example, something like this. We can aggregate some of the microservices and reduce the cross-region invocation. So every hop between the microservices is another line in the bill. So what we can do, I just make a checklist, and it's not necessary to be very complex. For the compute storage, what we can do is ask a few questions. Do we have some lower cost options? Have we reviewed the capacity and the performance requests? Does they match better to each other? And do we have life cycle policies in place for the data stored in hard disk or in storage account? Auto-scaling, introduce business-oriented metrics. Try to plan or design the stabilization windows or cooldown windows, and set up the concurrency model, not only inside of the infrastructure pod, but also can collaborate with the service application teams. They can do something even better than the infrastructure. And also, if we have cron jobs, we can set up some nights. We can hold these policies as well. Observability. What we can do, classify the logs, debug, ops, security, compliance, and based on the usage, set up different retention period. Also, we can work on the sampling filtering. Network, try to reduce the cross-region communication. That's really cost too much. And make the egress controls core consolidation. So we have a checklist now. And if your company doesn't have the document base, well, I assume most of us have that, either in Azure DevOps or somewhere else we made up by ourselves. And very often, a checklist, process, a lot of nice things, they just end up as a document because we don't access them anymore after we generate it. So it only works when we have them visible and as a part of the workflow. This is a very simplified the workflow. We coding, we create a pull request, merged and build test, deployed, and we monitor when it go to the production. So yeah, because this is how the engineers lives every day. They live with the pipeline. So we should put our cost of FinOps in the pipeline as well. This one can be more visible. What we can do, we have the pull request feedback. We make we definitely can have some estimations on pull requests before they get merged into the master or into the feature branch, a release branch. Especially, for the Terraform, ARMS template, whatever, we just work on the diffs, see if any huge infrastructure changes. Policy as a code check. It will be tested and try to be deployed. There are a lot of policy components in the cloud-native world. If you work in Azure, there are default open policy agent as well. I don't really like that because it will override my own policy, but there are some others you can utilize as well to check if there are any. Are you utilize premium SSD block? Do you have a default replica as a 5? No. Something like that. Do you have a tag applied for all of the resources going to be created after this deployment? No. Then I don't know where the cost should go. Reject the deploy. And also, engineering-facing cost dashboard. We, every day, working in the operation team, look into the latencies, with the uptime, look at the numbers of API calls, and we can also try to work out something like how much cost per request. It will give immediate reflect to the engineers how much it cost by the code they just pushed into the master. Yeah, design reviews. So many times, these kind of things will have to be done by different teams, especially for infrastructures. Sometimes they will say, hey, we have a full backlog, and many of them are high priority, and many of them are hyper-prioritized. We don't have capacity to work on the features. This is a new feature. No, they are not a new feature. And they are not a feature. They are non-functional requirement. The same as the performance, the same as the quality gateway, the same as the security. Non-functional requirement. Have to try to bring this into that man side. It's just so simple. If it ends up as a feature, you will never get priority. Yes. If it's not visible in pipeline, it won't be in the design either. That's one example. So this example is one project that has been worked on. It's also very, we actually have been touched a little bit already. This is a multi-region deployment, full data replication across the region, and all data in hot without lifecycle policy. So there are a few places can eat the money. The first is the multi-region, the data replication across the regions. And also that we do have service mesh in place already, so then we have the east-west in place. Very nice, technically good. And also data in hot, yeah. So this is how it looked like when I started working on the FinOps cloud performance things in my company. The first is what I did. Have a review of the replications across regions. Do we really need that many replica? We have 2 digits of the data centers across different geographic position. And as the calculation we just made, so each single terabyte of data, it will multiply 13 times. It's just horrible. And the storage cost take around 60% of our total cloud cost. So multi-region replication is also occurred the network bandwidth. Each time, it's just consume the inter-regional bandwidth. Now, not that much, because we have a service mesh as well. And all of the data gets replicated so many times when they end up to our production. No lifecycle policy. Outside, 10 terabytes of the customer data ingested every month, gets processed, integrated in production. Next month, we still get new data. Versioning, not enabled. And infrequent access to data, it's not there. So what happened done? We have enabled, there's a recent released Global Alive feature in Azure. Storage account is called Storage Inventory Report, which one of the metadata which emitted by this feature is the last access date, where you can find out the access pattern for each single object, which give a solid fundament to apply lifecycle management. How do you tiering the storage? Yes, multi-region deployment, do we need that many because the enterprise customer, they are so huge, and they give us so much money. We just make active all the way. We don't need that. So what we did, lifecycle management based on the storage insights. Of course, we compress the data before we put into archive. Data replication, from the 2 digits of replication, we remove to few of them. So we decide 3 of them as a major in the continental location, and we have 1 or 2 backups. So we reduce them to 4 or 5 replicas across the world, and also we reduce quite a few data centers if there are not restrictions or for the data storage. So only for this customer, they do require, for example, in the Middle East, they have to save the data in Qatar. And some of the customers, they have to save their data inside of Norway. Yeah. Otherwise, we have reduced the numbers of deployment as well. So the cost has been reduced. Storage cost, we were able to reduce after we put the lifecycle policy, about 30%. And this guy was huge. It will bring another 20%. And this just linearly cut the cost, because each data center can bring several hundred thousand cost. So what you can see, all of them has been done by the engineering team. So I want to say, if engineers are motivated and encouraged to do this job, they can make the most impact. Yes. So if there are 3 things we want to remember today, I want to say is the first, every architecture has a price tag. The second, engineering, they are really stay in the best position to run these activities. And the third one, cost FinOps is not a blocker. It are one of the most important non-functional requirements on the same level as performance security. And real savings are engineered. They are not negotiated. There are not many companies like the Gigant. They can get 40% discount from the Microsoft. We don't have that quota. So thank you, and hope your next invoice give you a better experience.